My name is Patrick Holland. This is a quick demonstration of a project I did for the class Computer Science 462 Distributed Systems at the University of Victoria. The project can be summarized as a massive database that is clustered and is easily scalable. The main tools used were MongoDB, Docker, and Docker Swarm specifically, AWS, and then there's a web app that hosts an API that runs on Node.js and Express. So I have the system up and running right now on AWS. You can see this is the AWS user interface, the dashboard for all my instances. I have 17 instances up and running currently. So they're all connected with the swarm, and you can see all of the swarm services right here. So there's currently 6 shards in the MongoDB cluster right now, so we can look at that with sh.status. We can see that there are 6 shards here, 0 through 5. And all of the rows of data currently are in the parts collection, so we can see how many. Right now I have just over 4 million rows of data in the database. So let's take a look at the sharding distribution of the data. So all 6 of these shards were set up before I started inserting data, and so the cluster just kind of chunked the data up and placed it in different shards. So we can see that here's a good one right here. So here's 16%, 21%, 12%, 10%, 9%, almost 30%. So that's how the data was split up across the different shards. I think the most that's in one shard is this one, 283 megabytes. So so it's not quite getting super full. Like there's 4 million rows of data, but none of the rows are very big in size. I think that if you were to start filling up the actual storage space on each one of these services or containers or hosts, you'd start to see a more balanced distribution, but it's still distributed fairly well. So for an example of how easy this system is to scale, I just spun up 3 more AWS instances here. They're all being initialized. As soon as they're ready, I will use this script I have here to join them all to the swarm. Once they're joined to the swarm, I'll start up one more shard, so that the database will go from 6 shards to 7 shards, and then I'll add maybe another million rows of data to it, and then we'll come back and check how that data was distributed. The instances are now ready to join the swarm, so I'll run this script here, and this will join the swarm for all of them. So the first one joined, second one joined, now the third one has joined, so they're in the swarm now. And I will run this script here. This is SSH'd into one of the AWS terminals, so it's the swarm leader actually. So we're going to add another shard to the cluster. The services are being created, so they'll take about a minute to set up, and we'll come back. So let's check on those shards, or the new shard. And yeah, we can see S6 is now part of the cluster, so there's 7 shards in the cluster now. And over here we have another million rows of data being added to the database. While that's going on, I'll just quickly touch on the replication. So each shard is made up of 3 services, or 3 containers, or 3 nodes, and that's just to allow for replication, which increases the availability. So that way, if one of the nodes goes down, whether it's a service or maybe the entire AWS instance goes down, then you're not gonna your system is not going to become interrupted. There's still going to be 2 or at least 1 node within that shard that is still available and is still able to process read and write requests. The data has finished being written, so let's go ahead and check on that. We'll just get a count again. So yeah, we're up to just over 5 million. We're at just over 4 million before, so about a million rows of data have been added. And now let's check on the distribution again. Yeah, so we can see shard 6 didn't get a whole lot of data here. It's only got 1.34%. but like I mentioned earlier, the database itself isn't getting too full yet. The storage space isn't getting close to being full, so it doesn't need to worry too much about distributing it very evenly. But MongoDB will, at times, do an auto-balancing type of operation, and it might move some data around if it feels like that would improve efficiency. So this was just a very quick demo showing the system in action and showing how easy it is to scale it. I have another video that's quite a bit longer that just kind of walks through the whole setup process. It's definitely not a guide of how the system is working behind the scenes and stuff, but it does show how everything got set up between the AWS instances and the services and whatnot.